There we go. Solve for x. Yay for algebra. Fell up the stairs. You fell up the stairs? Crazy. Alright, see what kind of memory you have about canceling out x values with a fraction and what the rules are. So that's number one, you're going to be canceling out to simplify. And then number two, of course, you're going to cross multiply and see what happens there. For those who are clueless on how to start number one, can anyone give us a hint what you would do first on number one? Think back to your algebra instruction. I can tell you what you can't do. You definitely cannot go, oh, x squared, and cancel them out. That is definitely what you cannot do, because you cannot cancel out over subtraction or addition. Order of operations. So who's got an idea? Oh, okay, thank you, Carson, for telling me. All we've done is the question of the day, now we're doing the warm-up. And someone is going to tell me how to start this warm-up. No. Sorry, nope. Because there's subtraction, we cannot do that. If that was multiplication, we could do that. But there's subtraction there. Do I need to end your misery? Nope. Okay. Nope. No. Okay, here's the answer. You need to factor. You need to factor the numerator and you need to factor the denominator. Nope. Cannot cancel the negatives. Y'all are saying illegal stuff. Illegal. I'm going to put you in math jail. Bad things. So, if we factor the numerator, we would get 56. What are we going to use? 7 and 8? 7 and 8? Okay. X minus 8, x plus 7. And then we go down here. Real quick, I'm going to pull a 2 out. So I've got a 2 here. And then x squared minus 49. This is called a difference of squares. I don't know if you remember that from algebra, a difference of squares. But I promise you it factors into x plus 7, x minus 7. It's called a difference of squares. Now that we did that, now that we factored, now we can start to cancel things out. Because now all that's left is multiplication. And you're allowed to cancel over multiplication. You're not allowed to cancel over addition and subtraction. But all I have left is multiplication. This is being multiplied by this. The 2 is being multiplied by this, is being multiplied by this. That's all multiplication. So now we're allowed to cancel. And we can cancel like terms. So we can cancel the x plus 7 and the x plus 7. The x plus 7's cancel. So what are we left with in the numerator? We're left with x minus 8. And in the denominator, we're left with 2x minus 7. You can also write it as x minus 8. And if you want to distribute, you can. But both of those are the most simple that we can make that fraction. So that was a trick. We had to factor it. There was a trick to solving it. Let's move on to number 2, where you're going to cross multiply. You can't cancel. No, wait. You can cancel over division and multiplication. You cannot cancel over adding and subtracting. Let me show you the difference. You cannot cancel those x's out. Bad. But if it was 2x over 7x, then sure, you can cancel those x's out. Good. Do you see the difference? In that first one, those x's do not cancel because there's plus signs. And the second one, that is multiplication, and so those x's do cancel. So that's the difference. Okay. Let's move on because we've already spent a lot of time. Let's move on. All right, we're going to cross multiply this, x squared, and then we're going to cross multiply this. And I'm going to go ahead and FOIL. I'm not going to write it out. I'm just going to FOIL straight away. So we've got x squared minus 2x plus 3x plus 6. I have to move this to extend my screen. There we go. Okay. What's cool here, what we're excited about, is that the x squareds actually do cancel. Because we've got a positive x squared on the left, we've got a positive x squared on the right, and so those actually do cancel. If you want to subtract x squared from both sides, you can do that, but I'm just going to cancel them. And I'm going to move my 6 over while we're at it. So I've got negative 6 equals negative 2x plus 3x. Well, which is x? So actually, that one was not as bad as we thought it was going to be. It ended up that things canceled and things simplified very easily. I got that EAG is absent. I got it. Thank you. All right, here are the first half of your homework answers. So go ahead and take some time to check your answers, and I'll go over like 3 or 4 of these, okay? When you have one you want me to go over, just go ahead and type it in the chat. You see any yet that you need me to go over? On the front? Okay. Can totally do that. Okay, Tahani, on number 1, you do 21 divided by 3. Well, you do 21 divided by 3. 7. Remember, we talked about writing a ratio in 3 different ways. So, 21 to 3 is also 21 to 3. It's also 21 to 3. There's 3 different ways to write a ratio. A ratio is a quotient. A ratio is a division. You're dividing. That's what a ratio is. Now, normally, if we divide it, and it's not a pretty answer, we would do math, enter, enter. But you don't have to do math, enter, enter, because 21 is divisible by 3. That's all you do. Okay, you want me to go to the back? I'm doing 10. I'm going to go to the back now. Let me know if you see one you want me to do. Oh, that's back from the front. Okay. So I'm doing 10, I'm doing 17. What else? Okay, 10 seconds. Anything else? Speak now or forever hold your peace. Last chance. You got the rest right? Can throw another number at me. I'm ready. No? Okay, I'll do 10 and 17. Okay, 42. Thank you. All right, let's start with number 10. Number 10 is going to be quick. All right. If you do not look inside the parentheses, don't look inside the parentheses. If you just look at the fraction, do you see any addition or subtraction? That is 2 times x plus y. That is 5 times x plus y. So there is no addition or subtraction. So order of operations says we get to cancel those. X plus y is identical to x plus y. They are the same thing. So it equals 2/5. When we see something in the numerator that's identical to something in the denominator, we're allowed to cancel it as long as there's no addition or subtraction. All right, 17. AC compared to AE. So let's find the length of AC. AC is 2 plus 5, 7. AE is the whole segment. So we've got 7, 8, 9, 10, 14. You're just adding up segment addition, 2 plus 5 plus 3 plus 4. And so that's where we get the 1/2. We always, always, always put our answers as reduced fractions, as simplified fractions. 7/14 would not be a good answer. All right, and number 42. 16 is to 4x as 4x is to 9. Oh, this one's cool. 4x is actually called a geometric mean, but we're not going to learn that until the end of next week. But anyways, when you see a number show up in those two spots, it's called a geometric mean. We'll learn more about that later to come. All right, so we are going to cross multiply unless you want to reduce first. We could reduce first and then cross multiply if you want. Like, what is 16 divided by 4? It's 4. So now we've got 4 over x equals 4x over 9. This is just an option. And now we can cross multiply. 36 equals 4x squared. Divide by 4. And is it a pretty number? We love when it's perfect squares. And we kind of already did that. 9 times 4, we're just undoing it. And so x is equal to plus or minus 3. And yeah, they should both work. There might be a better way to do that one, but I just went straight to cross multiplying. Okay, let's move on to today's lesson. It's called Ratio and Proportion Day 2. So we're really just going to continue with ratios and proportions, but we're going to do them within the context of word problems, not just simple algebra. So let's get started. Actually, while y'all are reading this one, I'm going to demote you all from presenters to just participants. That way I can do the poll and I can see what your answers are, so y'all can answer the poll and I can see who gets it and who doesn't. So I'm going to demote y'all while you're reading and working this problem. Work the problem. Stinks that I have to do it one by one. So I think if y'all answer in this poll right here, I think that y'all can't see each other's results. Will you tell me? So go ahead and type your answer in the poll. Can y'all see each other's? You can probably see each other's, can't you? No, you can't see it? Because I can see all the answers. Yay! Okay. All right. Way to put your units, Carson. But it says, what's the width of the actual building in feet? So be careful. Way to put your units, George. So we got Austin, Hussein, George, Carson, Albert, Helaman, Jenny. We're missing Kwan, Tahani, Taha, Adriana, Minjung, Brandon. I feel demoted. Ooh, I'm getting some interesting answers. All right, so my first, I would offer this advice first. I would just write a proportion. So there are multiple ways to write a proportion. You can put height over height equals, what are we doing? Width over width. Or you can do height over width equals height over width. I'm going to keep my heights together and my widths together. So the height of the building is 10 inches, and the width, the height of the actual building is 280 feet. The width of the model is 12 inches. Now, the good thing about proportions is that when you cross multiply and divide this, your inches are going to cancel and you're going to be left with feet. So the good news on a problem like this is there is no converting necessary. No converting necessary. You don't even have to know how many inches are in a foot for this problem, because inches over feet equals inches over, your answer is going to be in feet. So no converting necessary. So really we're just doing 280 times 12 divided by 10. So the final answer is 336 feet. The inches, like I said, the inches will cancel. Remember, if you would rather, you could have written it like this. 10 is to 12 as 280 is to x. And then your inches, you can really see how the inches cancel. Whichever way you like better, whichever way makes most sense to you. Okay, next problem. I'll let you read that and I'll clear out the chat or the poll. All right, when you're ready, you can put your answers in the poll. It's the same problem, just with a different context. Who's going to be first? Albert? Albert, your unit would be inches. Minjung? Hussein? George? Minjung, I think your answer's too big. Try your answer again. So I'm going to do width over width. So this is feet and this is inches. Width over width equals length over length. Remember, this is just one way to do it. If you want to do width over length, you can. And I put the real one on in the numerator, but you could also flip those as well. You could put the scale drawing in the numerator if you wanted to. All right, cross multiply 5 times 15 divided by 12. the final answer is 6.25 inches. Most of us got that. And if you didn't get it, I hope you know why. No converting necessary again, because it's feet over inches equals feet over inches. Nothing weird. All right. Let's do this one. Another bedroom. The ratio of a bunk bed's weight to the weight it can bear is 3 to 13. How many 40-pound children can a 65-pound bed hold? A real-world problem. This is totally applicable. You will see a problem like this on your quiz. If you want to star it, you will. I want to see who gets it first. So someone's having a sleepover, pajama party. How many people can get on that bed? Isn't that a cute room? That's so cute. George has got it. Mean Jung's got it. Jenny, you're off by 1. Those are the only answers I see. Brandon's got it. Helaman's got it. Jenny got it. Adriana's got it. I love how you're all putting question marks because you're a little unsure. Okay, let's get you started if you don't know what to do. So, the bed's weight to the weight it can bear. So, the bed's weight to the weight it can bear. So, this is the bed, its actual weight, and this is how much it can bear. Okay? How many 40-pound children? In my mind, I'm going to save this and I'm going to come back to it. Can a 65-pound bed hold? So where do I put 65? Is it the bed or is it the bear? 65 is the bed. It's a 65-pound bed. So we're going to find out how much it can bear. So we're going to cross multiply and we're going to get a nice ugly number. So 65 times 13 divided by 3. And we get 281.6 repeating. That would never be your answer. You never put a repeating decimal as an answer, but I'm not done. That's not my answer, so I am going to put a repeating decimal down. Now, that's how many pounds this bed can hold. Now, if each kid is 40 pounds, I want to find out how many kids it can hold. So if we take that number and we divide it by 40, we get 7.0417. So it can hold a smidgen more than 7 kids, but it can't hold 8 kids, right? And it can hold more than 6. It can hold 7. It can hold 7 and someone's stuffed animal. That's about it. So it can hold 7 kids plus a stuffed animal. So the final answer is 7 children. And remember, we put units all the time. Your answer isn't just 7. 7 of what? With word problems, we always want to answer with units. Yes, totally, you could put 40x in the proportion. That's a great way to think about it as well. 3 is to 13 as 65 is to 40x. And that would be a great way to solve it. Very good. I like that way too. Moving on. The ratio of the side lengths of a triangle, we're actually going to skip this one because we did one like this yesterday, the flagpole one, and this was on your homework a couple times. So let's go to one that we haven't done before. This one's kind of weird. So I want you to be exposed to it. Ooh, don't those cookies look good? That makes me hungry. You're baking 4 dozen large cookies for a party. You need half a cup of mixture for each cookie. So like that's huge. Those are huge cookies. Did you notice that? I just noticed that. So you're taking a half a cup and you're digging it into the cookie batter and you're like throwing it on the cookie sheet. I guess they're not that big. Anyways, I usually use a 1/4 for each one. The recipe calls for cookie dough, chocolate chips, and walnuts in the ratio of 6 to 3 to 1. How many cups of each ingredient do you need? So I'm going to give you a few minutes to think about it. Your answers are going to be ugly, so I will warn you of that. You can put them as a fraction or as a decimal. I like fractions better, but I guess in this one a decimal would be a more real-world application. But I'm just going to let you think about that. Too big. Mean Jung, too big. Could you imagine 240 cups of walnuts? Or of cookie dough? No, too big. Still too big, Helaman. That's going to make more cookies than you want. George, first one. Good job. George has got it. Carson, you found X, but tell me, that's good, Carson, that's X. Find out how many cups of each ingredient you need. Good, Taha, but go ahead and label those, and you're a little bit off. One of those numbers is right. You need to label which one's cookie dough, which one's chocolate chip, which one's walnuts. Nope, Brandon. Okay, let's go over this, okay, because I want you to get this right on your quiz. All right, so the first thing I did when I read this problem is I scratched out 4 dozen, and I wrote 48. So I am making 48 cookies. When I leave for the party, I better have 48 cookies in my hand. Now, I need half a cup of mixture for each cookie. So I need half a cup of mixture for each cookie. So how many cups of mixture do I need? Well, I've got 48 cookies, and each cookie needs half of a cup. So if I multiply that, I need 24 cups of mixture. I need 24 cups of mixture. Okay? Now, each of those things are in a ratio of 6 to 3 to 1. So we're going to have a lot of cookie dough, a little bit of chocolate chips, and a tiny bit of walnuts. So 24 equals 6x plus 3x plus 1x. I just took this and added an x to each one, just like we did the flagpole problem yesterday. All right? So 24 is 10x. So x is 2.4. 2.4 is like our ratio. It's like our common ratio. It's that product, the common product, okay? So I need 6. This is our common product. I need 6 of them to get me my cookie dough. I need 3 of these parts. Let's do that. To get me my chocolate chips. And I only need 1 of these parts to get me my walnuts. So 2.4 cups of walnuts. And then what were the other ones? 7.2 cups of chocolate chips and 14.4 cups of cookie dough. I hope that makes sense. Yeah. Not times 2, times a half, because each cookie gets a half of cup. cups of the dough. Woo! Okay, let's try another one. I am recording this, so if you have to go home and watch it again before you take your quiz tomorrow, you can. You just won a prize trip to Italy! Yay! You go to the bank to convert $300 to euros. Maybe that's going to be your spending money while you're in Italy. If the current exchange rate is 1.36 US dollars for 1 euro, how many euros are you taking in your hands with you to Italy? Let me open the poll again. And this is our last problem of the day, if you were wondering. I know it's been quite a bit of a lesson. Good, Kwan. Good, Minjung. Let's round to the nearest, well, euros. I don't know what they're called. Let's round to the nearest hundredth, though. What is the symbol for euro? I can't remember. Is it like a little E? Yeah, that's what I thought. Like this? Like that? Is that good, George? Okay. All right, so if you want help setting this up, if you want to do, the moral of the story is you're going to do 300 divided by 1.36. But if you want to know like where the math is and how to set it up, what I would do is 1 euro is $1.36. So I'm putting euros over dollars equals euros over dollars. So that would be the actual math way to set it up. Yeah. Euros over dollars equals euros over dollars. So then when you cross multiply, you do 1 times 300 divided by 1.36. And you get 220.59, yeah, 220.59 euros. Is that it, Austin? Is that the symbol on the keyboard? Okay, we are done. Oh.